Hello everyone, the topic for today's video is binary adder. A binary adder is a digital circuit which adds the contents of two registers. Like following the register statement R3 R1 plus R2. What this register statement means is the contents of R1 and R2 are added and that result is stored in the register R3. So to implement this micro operation, we need registers which store the data in R1, R2 and R3. These are the registers, and a digital circuit to perform the add operation. And we know the digital circuit which is used to perform add operation is a full adder. And so the binary adder is a sequence of full adders. So let's see what a full adder is in brief. This is the circuit of a full adder, the general circuit. So it has three inputs like A, B and Cin. Cin is the carry from the previous full adder if it exists, and its outputs are sum and Cout. So let's see how this full adder works. It just adds the inputs A plus B plus Cin. Okay, so consider A is 1, B is 0 and C is 1. Then we have 1 plus 0 plus 1, which is 2, and its binary equivalent is 1. So we have a carry here. The sum is 0 and the carry Cout is 1. And then consider 1 1 1, all the inputs are ones. Then we have the binary equivalent 3 is 1 1. The carry out is also 1 here. And then consider 0 0 and just the carry in is 1. Then the sum is 1, so the carry out is 0. So this is how a full adder works. Now let's see what a binary adder is. The binary adder is constructed with full adders connected in sequence. So we see here 4 full adders, FA1, FA2, FA3 and FA4. These are connected in sequence. The carry out of a first full adder is connected to the carry in of the second full adder. This binary adder is a 4-bit binary adder because it has 4 full adders. What I mean to say is a n-bit binary adder requires n full adders. Now let's consider an example to see how this binary adder works. We have the registers A, B, S. So the micro operation here is S, A plus B, which means the contents of A and B are getting added and it are transferred to S, the register S. So we have A, which is 1 0 1 1, and B is 1 1 0 1. Consider this. Then we'll have the sum. Initially the Cin value is always 0 for a binary adder. Okay, from the example we have A naught is 1 and B naught is 1 and Cin is 0. So 1 plus 1 plus 0 is 2, whose binary equivalent is 1 0. So S1 is 0 and the carry is 1. Now A1, B1 are 1 and 0 respectively. So again 1 plus 0 plus 1 is 2 and we have a carry out 1. Now A2 and B2 are 0 and 1 again. So the sum is 2, that is 1 0. We have a carry out 0, carry out 1. And then A3 and B3 are 1 and 1. So the sum is 3 and its binary equivalent is 1 1. So we have Cout 1 and S4 as 1. So the value of the register S is 1 0 0 0 because the maximum capacity of the register S is 4 bits. But we just missed a bit over here, that is the carry out bit, without which the answer does not make any sense. So we also need to include the carry out bit. So the answer would be 1, which is the carry, and 1 0 0 0. To also include the carry out bit along with the contents of S, we need a flip-flop. Flip-flop to store that bit, which is known as E, that is an extended carry. So this is how a binary adder works. Hope you liked the video, guys. Thank you for watching and subscribe for more tutorials.